Right, let's pick it up. Yesterday, I hadn't had enough sleep and I was cranky, so I didn't get the type thing at all. I got super confused. I did a little bit of cheating, cheating last night. Yeah. So we should be fine. Let's... Right. So, whoops. Well, types, the thing that threw me off, right? Normal types like integers, floats, doubles, bools, characters, those are all fine, right? That's just typical types within programming. The thing that I had a problem with, well, and then we have type variables, that's fine as well. It's just a placeholder for any type. I like that. We can think any, yeah. So head takes a list of any type. Yeah. You can get a list of booleans, you can list of whatever, right? And then... Right, so that's the type. What threw me off a little bit is that, right? This here, this whole thing, is it's like the type of head. Right? It's the function. It throws me off a little bit. It still does throw me off a little bit that, right, we're looking for the type of the function. This is the type of the function. It's similar to how each tuple is its own unique type. Each function has its own kind of unique type. Right, so it's defined by these things, right? So type classes then becomes fairly easy, right? It's like, oh yeah, if we take, if we check for equality, this function, then yeah, we take anything and we compare it with any type with any type, and then we spit out a bool, right? We make a group, right? So it cannot be any type. It has to be any type that can get the EQ. What was that called? Type class, right? So it's a set of types that can be EQ. Yeah, right. All of these, indeed. Right, so EQ is pretty straightforward, right? It's all the sets that can be equality tested, indeed. Member of EQ, exactly. And these are all members of EQ. Yeah. These are members of EQ. Thank you. That's a good way of looking at it. Wait, no. These are functions. Right, but the members of EQ are like these. All the integers, the ints, the integers, the bools, the strings, the characters, right? Almost everything is part of the EQ. I think so. And then ordering is another type of collection of types that can be ordered, which is straightforward. And this function takes ordered types. Yeah, straightforward. Same, this confused me, the show and read, because show and read takes a specific type class, right? The function has its own type class, pretty much, right? Yeah. Show and read has their own. Well, these are the type classes. But they do, yeah, so they have their own unique type class, indeed. Colgate Genotypes as well. Almost everything that has been in the book so far is a member of EQ. Yeah, almost everything, yeah. Most things. And that we can just test out, right? and that it all makes sense. This is where I kind of got lost yesterday, I think. But it's kind of straightforward. It says that... right, I was confused. Why does it say A here? That's because when we... Wait, how was this? If we do T read, right? It refers to this A, right? Ambiguous type variable A. It's this A. Right? This A here has not been... it's ambiguous, right? Like you can have... Like if we take a... what was the tuple again, right? You got A and B. That's so... The error message helps us to figure out which one is the broken one. And then we get where it is. Right? Why is it broken? Where is it broken? Right? It helps us identify, and it gives us some help indeed. Colgitinotab says, if you make your own type, it is not a member of any type class by default. But I assume you could make your own type and make it part of a type class, but that seems like redundant work, but yeah, we'll get to that. Ambiguity, because 4, it can be anything, right? This can be a character, it can be a string, an int, a num. Yeah, we don't know with the read what to do with it. Olgitinotab says, yes, of course, but later, yeah, later more about it. Indeed, let's not get ahead of ourselves, indeed. So where were we? I think we read all this. Yeah, and this is... Right, when you want to... What was that? Contains, right? Read 5 contains an integer. That's the word that I started using for the double colon. Yeah. Read 5 contains an integer. Read 5 contains a float. Wait. Oh, yeah. And if we want to... I was thinking about that. If we want to have a tuple and we want to define this character, we couldn't just do this, right? If we do... if we do this... Wait. This must break, right? If I just do... That breaks. Exception. Prelude read? No, parse. I don't know what that means. I was hoping for a better error. Has type of. Alright, has type off. That's one way of putting it. And we get some exception, prelude.read. No parse. Wait, did I do something else bad? Maybe that is just it. And just double check that this works. Yeah, that works. Yeah. It's that it's not... I wish the error message was better. What about... What about if we do char? Yeah. It breaks. But we can do... Wait. Why doesn't that work? Can't we have a type class here? Isn't num a type class? Yeah. Integer. Integer works. Oops. Float works. No, it must be a type. I used that. Has type off, like you said. It doesn't say has type class off. Right. Because type class is this syntax. Where is it? Here we go. That's not what we're doing. So, what I could do... I could do... Wait. What if I want to do a type class? You know what? Let's skip that. We don't care. We don't care how to do these things. Not yet. We need to get a better grasp of what's going on. That's the goal. Yeah. Alright, so most expressions are such that the compiler can infer the type by itself. Indeed, yeah. Right. If we want to do something though... yeah. I remember this. Hey, this expression should have this type, just in case you don't know, right? We might be in a situation where we have to do this, but hopefully that's not the plan. Alright, enum, another type. Yeah. And that's LTEQGT. Wait. Members that are sequentially ordered. Yeah, exactly. So that's all of these. They can be ordered. And you can use my favorite function on these. Yeah, my favorite function indeed. Colgate on tab says, if you told Haskell you want it to be read as a member of num type class, it still wouldn't know which type you want exactly. So that would be unnecessary because it's statically typed. It needs to know. Yeah, that's the whole point, right? It's statically typed. It needs to know which type it is. Type classes are only good for our functions. That we can design a function that can work on many different types. Right. For example, this enum function that can be used on all of these things. Tuples, bools, characters, orderings. Shit. Did we read about ordering? Right, what did... Right, so let's see if we can figure this out, right? Ordering. No, wait. How do... we did read about ordering. I know, I mean... I remember I confused ord and ordering. I remember that. So ord is the function. Is that it? Ord, and then we take a list of like 1, 2... No. 2, 1, 3... No. Oh, is this ordering? Oh, right, it takes two things. Ord takes two things then. Ord is type class, ordering is type. Right, so what function do we use for that? Is it just this, right? How do we return LT? There was a function for it, right? That they used the infix. No. I know neither of them are a function, but there is a specific function to get these outputs. There was a specific function that gives these as outputs. I don't remember the name of it. I'm terrible with names, you know? Alright. Here we go. Ord. I saw it. Compare. That's the one. Compare. What was the difference between ord and ordering? Right. Oh, type and type class. Right. Ord is the type class. Ordering is the type, exactly. So, this is what I wanted to do. Yeah. Exactly. It takes a type class of ord A and then... Exactly. And then we get the ordering value, which is these things. Yeah, that makes sense. Well, Gitino tab says ordering, boolean, int, and character are examples of members of ord. Yeah. Yeah, exactly. Wait. And all of those as well can be enumerated. Wait, can't... Shit, I forget. No, right. Ord is a type class. Enum is a type. Oh man. No, this is a type class as well. Right, it's a list of things. It's when we have a list, that's the comparison. When we have a list of things that can be part of the ord type class, that, right, they can be in no. Enum is also a type class. So, what's the difference between ord and enum? Enumerate. Right, enumerate doesn't talk about bigger or smaller, it's just you can put them in an order, right? You can enumerate, right? Ord, if I would take... right, in enumerate, one is not bigger than the other. Yeah, like we can do... like 1A, 2C, 3B. Oh shit, sorry, this is not real code, right? But this would be an enumeration, right? A is the first, C is the second, and B is the third. There is no implied order in enumerate, right? This is completely fine. While when we're in order, then B is smaller than 2. That's not it here in enumerate. Yeah, so that's the difference. Strings are members of ord, but not enum. Right. But strings that becomes derived from the character, right? The first character of the string is how they got ordered. I'm pretty sure. Right, if we do compare axe, and dog, right? Now I understand why we want the infix. Compare. Less than. Axe is less than. Yeah, exactly, because dog is... It comes after. So axe is less than. That's why I got confused. Because A is smaller than D. Right. Still, yeah, it's not the length of it. And lists of members of Ord in general. Wait, I don't know what you meant by that, Colgating on tap. Right. Bounded. Are these the only bound things? Not that int are, but integers are not. Characters are bound. Oh, booleans are bound. Of course, yeah. Not many booleans. String is a list of characters, for example. Alright, so list of members of Ord in general. Oh, yeah. Like, so any list, right? If I do, I can do compare. Right, we do 1, 2, 3, and 2, 3, right? It's gonna be less than. Exactly, because it starts with 1. It compares 1 to 2. That's how compare does it. Right, or... Yeah, I don't know why you're saying the things you're saying, Colgating on tap. I missed out on the context. Lists of members of Ord in general. I don't understand what that sentence means, right? So the rest of the things I don't understand what you're trying to say. Right. Min bound, max bound are interesting because they have a type of bounded A. They are polymorphic constants. Oh yeah, min bound and max bound. They have a bounded variable and they return said variable, yeah. Alright, the difference between enum and ord. Yeah, I think the way you explained it is just way confusing to me. I think you're trying to explain it like a mathematician, yeah. I think I got the difference before. Yeah, right, that numerate just gives stuff numbers, right? It numbers them, while ord orders them. Right? Enumerate doesn't care about greater than or less than. Yeah. I need to understand it like a linguist, a philosopher, not a mathematician. So the way you explained it is just, I'm more confused now that you tried to help with the way you're trying to explain it. I assume some people would understand it like mathematicians, yeah. Right, all tuples are also part of bounded if the components are also in it. All tuples. That was a weird sentence. Didn't understand that sentence either. All right. Num is a numeric type class, right? That's all the numbers have the num type class. Oh, wow. We can just do this. The type of 20. Yeah. It's a num type. We don't know which one because it can be any one of them. Yeah. It appears that whole numbers are also polymorphic constants, that they can act like any type that's a member of the num type class. Yeah. This all makes a lot of sense, yeah. We have a specific type class where all of these are members. Yeah. Those are types that are in the num type class. If we examine the type of multiplication, we see that multiply. I don't know. We'll see that it accepts all numbers. Exactly. But not all of them do, like... Yeah. It takes two numbers of the same type and returns a number of that type. Right, so when we try to multiply an int with an integer, that will result in an error. Right, because you can't multiply an int and an integer. However, if we just do this, yeah, it will... what's that called? Infer that this is an integer as well. Right? Will work just as fine and produce an integer because 5 can act like an integer or an int. Exactly, right? To join the num type class, type must already be friends with show and EQ subclasses. Right. Integral is also a numeric right. It's also a numeric type class. Num includes all numbers, including real numbers and integral numbers. Integral includes only integral whole numbers. Right. In this type class are int and integers. Oh, I didn't know that. Integral is an integer. And the first 3 letters kind of implies it. Or the first 5 letters. Right, so integral and floating. There we go. That's my knowledge before this was that we had ints and we had floats. We have integrals, not integers. Not in Haskell, that is. A very useful function for dealing with numbers is from integral. It creates, I'm assuming that it creates a floating number from an integral. That's got to be it, right? It has a type declaration of from integral. It takes any number, yeah, any part of any num type and an integral type. Oh, it doesn't create a floating number. It creates a num? Oh, right. It's like we have a little tree here, kind of like we have. Right, we've got num here. Actually, let's do that. And down here we have integrals. And from them we have int and integers. All right. Something like that. And num is over here. And we've got floating. We have a structure kind of like this where we have, yeah, float and double, right? So when we say from integral, it's if we happen to have one of these, and we want to work with the people over here, we move it up a level, kind of. It's like a hierarchy of different types of different type classes. Yeah. Colgate Unotab says we have integers, they are members of integral. Yeah, integers, right here. Integers and ints. Right, that's what it said. Int and integers, float and double. You can put show or equal over num. Oh yeah, but I'm thinking, right? I'm thinking about numbers right now. So we could... Oh, are you saying that the entire type class system is a big hierarchy of... Is it... So if we put... Right, you can put show or equal over num. Right, because they have to be, right? So we can put show and EQ over here. And this is like an hierarchical structure. So, well, the tree doesn't work anymore. It becomes more of like a... You would have to make a mind map, right? Because from show you can go to num, but you can also go to other subclasses away from num, right? So it becomes more like a map rather than a tree. Melanol the Destroyer says, when you know that math is just logic, it is easier to get it somehow? I don't know. I think logic is pretty difficult. And I think using the word just is kind of giving both math and logic a bad reputation. Like, it's just logic. Like, logic was this... Logic is amazing. It's amazing. It took thousands and thousands of years to build up a system of logic that is as logical as the current system. Yeah. The system of maths is as logical as it is. It's cool stuff. Yeah. Math has many other fields as well. Oh, well. He was kind of pointing out, right, that math, logic, right? Under logic we have deduction, like we have a tree here, right? Induction. Math is, wait, we have first order logic. That's math, right? Right, and over logic we have philosophy, right? In a hierarchy thing, and we have, I don't know, empiricism. I don't know. No, we don't have that under philosophy. We have that under... Right, we have many other things, so we can spread it out and make a map out of philosophy as well. Right, this here, good to know. Also skip that for now. This is fine. Yeah. Exactly, because here we get from integral, good naming convention. We take an integral, let's A, and we get a num, B, right. From its type signature, we see that it takes an integral number and turns it into a more general number. That's useful when you want integral and floating points to work together nicely. Indeed. For instance, the length function has a type declaration. Length. Right, it takes a type. Yeah, it takes a list of something and it comes out as an integer. No, an int, sorry. Integer and int is not the same in Haskell. Int is bounded, while integral, well, integer is unbounded, can be infinitely long. Right. Instead of having a more general type of... Right. Yeah, it has this instead of having a generalized. All right. And of course it's an int. It could have been an integer or a float or a double, but none of them make sense because it will, right? This will, it's type inference again. It will be whole numbers. Yeah, they will be integral. And of course we use an int because that is, I'm assuming, what's that word? Optimized. Yeah, it's more optimized than integer. If you can use an int, you should use an int, not an integer. Yeah, to take less memory. Alright, instead of having a more general type, right, take an B. Yeah, because this more general type, this wouldn't be optimized at all. Because even though we would maybe want to use a float or a double or whatever, that is not what it's getting, right? We won't get that from a list, from how long a list is. Yeah. I think that's there for historical reasons or something. Although, in my opinion, it's pretty stupid. Wait. I totally disagree with the writer of this book. I don't think that's stupid at all. I think this makes a lot of sense to have an integer instead of a num class. Isn't that usually... because of the inference? Anyway, if we try to get length of a list and then add it to 3.2, we'll get an error because we try to add together an int and a floating point number. So to get around this, we do from integral and... yeah, exactly. And all works out. Right. That's why you are strict with types, because it's more efficient. Notice that from integral has several class constraints in its signature. That's completely valid, and as you can see, the class constraints are separated by commas inside the parentheses. All right, so we got to see this then. From integral. Oh, right, we already saw this. Yeah, we can have an as many variables as the function takes, as many type classes we can have. All right, I feel much better about type classes today than I did yesterday. Yesterday I was just didn't get anything, but today it feels like, yeah, it's just you just collect a couple of types together and you call that a type class. When they have similarities that are worthwhile using in functions. And that's why we do the type inference thing, to be able to do this. Because num is very useful. Right. Syntax in functions. Oh shit, I completely forgot how to do functions now. So it's good timing, good timing for checking on syntax. Maybe it's time to write some things? Hello world? Hello, Divine Sniff. I love your username, Divine Sniff. Hey man, good luck on your journey. I had a similar class last year. Nice. Oh, I don't have a class. I'm just learning Haskell for fun, yeah. But thank you, and so far it's been difficult, but we are getting it. It's fun stuff, right? Syntax. So how are you doing today? Are you happy knowing Haskell, Divine Sniff? Get on tab says, yeah, Hello World is in chapter 9. We're not that advanced yet. That's how it feels, yeah. Stay away from the functions, no jumping ahead. Right, pattern matching. Right. This chapter will cover some of Haskell's cool syntactic constructs, and we'll start with pattern matching. Are we not going to be using regular expressions? Is that it? Divine Sniff says, to be honest, it was tough at the beginning, but it all clicked after some practice. Yeah, that's what I hear. That's what I hear, and that's why I'm learning Haskell. Not necessarily to be to write in Haskell, but it's just to understand a different way of thinking about programming. It's fun to learn, yeah. And it is. I heard somewhere it's like it's a programming language for math professors by math professors, kinda. And I'm not a maths person, like maybe a little bit, but just a tiny bit. Most of it is just I'm not very good at it. Right. Maybe not regular expressions then. Pattern matching consists of specifying patterns to which some data should conform and then checking to see if it does and deconstructing the data according to those patterns. Wow, this actually sounds fun. Yeah. It seems like a step above regular expressions, right? Regular expressions is just for strings. This is just pattern matching in general. Right. When defining functions, you can define separate function bodies for different patterns. This leads to really neat code that is simple and readable. You can pattern match on any data type, numbers, characters, lists, tuples, etc. Nice. Let's make a really trivial function that checks if the number we supplied is a 7 or not. Lovely, I like that. Melanol the Destroyer says, I have no talent at math, but I spent a shit ton of time and still suck. You can do this, just like me. Yeah, I mean, I can do this. We can do this. Yeah. Alright, Lucky 7. Alright, that's our function name. What was this called again? What do we call this part of the function, right? If we want to name the different parts of the functions, we call this type definition, type, right? We explicitly tell Haskell, the compiler, the types of the functions, right? Which types we are gonna be using. That's good enough. I'm terrible with names. I don't have to know the name. I need to know the function of this line. Yeah, we specify. Type specification. There we go. I made my own name. Right. Right. We take a variable that has to be part of the integral type class, and we get a string back. So, Lucky 7. If we get Lucky 7, then we return the string Lucky number 7, yeah. And Lucky all the others are... Sorry, you're out of luck, pal. So screwed. Colgate says, without that line, Haskell would think it is num rather than integral. Oh, yes, it would. It would indeed. Why integral? Why not int? Actually, I feel this is some time for science. Ah. That is something I can test without issue, right? We're gonna do this. We're gonna do a lucky. And we're gonna just copy this straight out. This is how you copy and paste, right? Yeah, you type it by hand. Right, A, and then into a string. Right, and then we say lucky 7 is equal to, yay, and lucky x is equal to fuck off. There we go, all caps. It's got to be caps, right? Right, and this is fine. Right, we load test in here, one module loaded, right? And then we call lucky 4, fuck off. Lucky 7 is great. Then we call lucky max bound. Shit, how was this again? We just tried this. Oh, we had it right here. We had... Right, max bound. Not like... Wait, can I just do this? Oh. Yeah. So we do that, and actually I'll get another parentheses in here just to make sure the order of operations. I take +1, right? Boom. Now we're sure that it is an integer, right? Because I took the max bound +1, that makes it an integer instead of an int. So I'm curious, what if we do this now? Int. And we reload. Wait. Int is not a type class. Can I do this? No, I can't. I would have to write what I wanted to do. Yeah. It would be this, right? This is what it would look like. Yeah, that's illegal. Right, and now when we try to do this thing again, it will break. No, wait. Wait, it doesn't matter, right? Why doesn't it break? Right. Oops. Oh, look at that. That is why it doesn't break. it loops around. Yeah, it circles back. Divine Sniff. So it doesn't break. It breaks, but it does not break as in an error message. It breaks as in just circling around. That's an interesting way to deal with the ints. That it doesn't throw an error like saying out of bounds. I would have thought it would just go and say, no, this is out of bounds because the max bound is this, and if you try to add something to it, no. That's what I would have thought, yeah. Is there a benefit to circle back or circle around? Like a reason for why it works that way? Right. But this is a bad way of doing it, yeah. Yeah. It is way better to when you go in. Actually. What is the benefit of doing this at all? Why not just... why not just do this? Since we have type inference, right? Right, because we could, right? We could do... all caps, yeah. Super, right? We could do that. I guess. No? Is it because this can't be a list? Wait, why wouldn't it... Right. Let's do this one more time and read. What's the error? Couldn't match the expected type A with the actual type. Right, so this can't be a list of characters. A is a rigid type variable bound by type signature for... Oh, that is something I had completely missed. So A is not a list. It's just the types, and list is not a base type, right? So, right. And that's why they have been talking about making smaller, easier function and then making them more complicated, right? All right, good thing to try out, to remember that this will not be a list. We would have to, right? If we want a list or a tuple or whatever, we would have to put this in the definition. Does this break? Since this is not a list, and this is not a list. Does it break because both of them, or just the one? Oh, it broke on 7, yeah. And now it breaks on X. No, wait. X can be a list? Oh, right. Down here it can be. Yeah. Right. It's up here it can't be. Looking out. Right. What does it say? No instance for quality. Okay, rising from the literal 7. Add. Wait, I'm confused. Now I'm confused again. Why do we... why do we have to add the EQ type class? But we're not doing any... We're not testing any equality, are we? Oh, no, we are. Right. Will we have a list of 7? Oh. Wait. Why did it work to just have... Why does this work? Oh, it doesn't work. It actually tells us. Yeah. We have to have a type class. Because we have the number 7, it actually tells us, yeah, you have to have a type class. And EQ is a top higher on the hierarchy than integral. Interesting. When you call lucky, the patterns will be checked from top to bottom, and when it conforms to a pattern, the corresponding function body will be used. This is kind of... This looks very much like an if-else statement. But we're not saying if, we're not saying else. Right? Lucky. Oh, is it 7? Yay. No? Then fuck off. Colgate on the tab says it is similar control structures. Oh. Now Donor says, hi, I'm new. Isn't it past your lunchtime? Wait. A minute passed. Actually, we started a little bit late with Haskell today. Nice to see you again, Node Runner. Yeah, it is a little bit past my lunchtime, but I'll go a little bit over today. Yeah, a few minutes over. Or maybe not. We'll go for a few more minutes. Just got started on pattern matching in Haskell, so I want to understand more about pattern matching. Right, the only way a number can conform to the first pattern is here is if it is 7. If it is not, it falls through the second pattern, which matches anything and binds it to X. This function could have also been implemented by using an if statement, indeed. But what if we wanted a function that says the numbers 1 to 5 and says not between 1 and 5 or any other number? Without pattern matching, we would have to make a pretty convoluted if-else tree. However, with... Yeah, because there are no loops There are no loops in Haskell, so that would be very convoluted. No, says, I'm not earning social credits because I'm using MPV. Shame on me. Oh no. Yeah, well, it checks out, doesn't it? But not shame on you, right? There are better things here in life than to earn social credits. Yeah. Actually, if I was the dictator, I would say you would earn double social credits by using MPV. The system is broken. Yeah. The system is broken. Wait. What's that song? I'm thinking of a Megadeth song. If there's a new way, I'll be the first in line. The system has failed. There we go. That's the quote. Alright, say me. Alright, I kind of want to say that if we... Right, I would say... let's see. Say me... Let's keep doing that. Sure, let's go for an integral. Actually, let's... Fuck that. We'll make it easier. We just take ints, nothing else. Int into string. Does this even work? We'll learn, I guess. But I'm thinking... Right. Say me... Oh, wow. That went well. Say me, and then I'm thinking that we, in parentheses here, we do... lm. And then we take a list. 1 to 5. No, shit, that's not what we do. Shit. How do we do that? I'm thinking... Right. Yep. All caps. And then... Say me... X. That's... Nope. Alright. Feels like I'm doing something wrong here. Node says, the system has succeeded in creating an incentive structure that promotes harmful activity. That's not a failure, that's a success. Well, that depends on your point of view, doesn't it? That's why I said from... Wait, what did I say? If I made the rules. Yeah, if I made the rules. Because... How do you evaluate? It's a subjective value judgment, right? So from my point of view, that is a failure, not a success. You'd need guards for that, which is later. Yeah, this doesn't work. I can't do that here. But it's later. But you could do something like this, but... This would probably... Right. We'll get to this later, yeah. Let's walk before we can run. Indeed. That would be... I think my thoughts worked, but my syntax was all out of whack. But it would be doable to do something like that. But maybe through guards or some other way, yeah. Node owner says, somehow